Hello everyone. In this lecture, we are going to discuss basic functions that are used a lot in calculus and mathematics. I will be discussing 7 functions. So linear functions, quadratic functions, square root function, exponential function, cubic functions, and absolute value function and reciprocal function. These are different types of functions that we have out there, and we call them basic functions. The equations are in green bubbles. Y equals x is the basic linear function. Y equals x squared is the basic quadratic function. I know that the quadratic function is in the form of y equals ax squared plus bx plus c. Okay, I know that. But the basic quadratic function is y equals x squared. The easiest case, basically. That's why we call it basic. Or y equals square root of x. That's the square root function. Y equals 2 to the exponent of x is the exponential function. Of course, the base instead of 2 can be 3 or 10 or whatever, but I selected 2 for simplicity purposes. You don't expect me to select like 10 to the power of x. And then cubic function, basic cubic function is y equals x cubed. Absolute value would be y equals absolute value of x. And y equals 1 over x is the simplest actually rational function known as a reciprocal function. So the graphs are drawn here, but if you wonder how we can come up with these graphs, you have to grab a graph paper actually, and you have to construct a table of values for each one of them, and with patience and dedication, plot every single point that you calculate in the table of values, and then you draw a smooth curve passing through those points, and this way you will see how these graphs are obtained. I have already done that. So the x values I have selected, okay, I selected the independent variables values, and the values of y I have to calculate according to the definition of different types of functions. So f of x is equal to x, so that means that whatever I have for x, I will have the same thing for the y. This one is y equals x squared, which means that I have to square the independent variable value. So it's going to be 9410149. You have to square 3, square 2, and so on and so forth. This one, I have to take the square root of the input number. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, 3, and square root of 16 is 4, obviously. This one is 2 raised to the exponent of x. So 2 to the exponent of negative 2 is actually 1 over 2 to the exponent of positive 2, which is a quarter. So this is going to be 0.25 or a quarter. 2 to the exponent of negative 1 is 1/2 or 0.5. 2 to the exponent of 0, or actually any number raised to the power of 0, is equal to 1. And 2 to the exponent of 1 is just 2. And then 2 squared is 4. And 2 raised to the exponent of 3 is going to be 8. So these are the values of y that we calculate. You can do mental math or use the calculator. Cubic functions, okay, we are cubing this time. So negative 2 all cubed is going to be negative 8. Similarly, negative 0, negative 1, and then 0 cubed is 0, and then 2 cubed is 8, 3 cubed is 27, if I'm not mistaken. 3 times 3 times 3, right? Next one, absolute value. We have extensively discussed that in a separate lecture, obviously. So it's going to be always the positive value. So that's very easy. Reciprocal is very clear. So you do 1 over the x value. So this is going to be negative 1/2, and that's going to be negative 1. This is going to be 1 over negative 0.5, which is actually negative 2. Then this one is positive 2, this is 1, and this is 0.5 or 1/2. 1 divided by 2 is 1/2. So table of values, you have to, as I said, patiently and in a dedicated manner, grab a nice graph paper, and one by one plot these points and see if you can get the shape of that basic function or not. I highly recommend that you do that, actually. It's extremely important. Now that we have the graphs, I've already plotted them. You see how the shapes look like. You see the table of values. We want to discuss their properties. X-intercept. Well, here the x-intercept is clearly 0 because the graph passes through the origin. So x equals 0, and the y-intercept is also 0. For the quadratic function, x is 0, y is 0. But again, the parabola, which is the name of the quadratic function's graph, is passing through the origin, so 0, 0. This one, the x-intercept and y-intercept is also the same. You see that many of them have the same x-intercept, y-intercept because these are basic functions. This one actually does not intersect the x-axis at all, because as the graph, as x actually approaches negative infinity to the left, if you select like very, very small numbers, like negative 10 million, for example, then 2 to the exponent of negative 10 million is a very, very small number close to 0, but still it's positive. So that means that this graph is above the x-axis all the time, and it never ever intersects the x-axis. You may remember that the x-axis is called the horizontal asymptote of this exponential function, and the graph does not intersect its horizontal asymptote. Therefore, because the graph does not intersect the x-axis, there is no x-intercept. So I'm going to say no x-intercept, and it's not your fault. That's the nature of the function. But the y-intercept is actually 1. Okay, y equals 1 is the y-intercept. In fact, if the base is 3, 4, 10 million, it doesn't matter, because even 10 million raised to the exponent of 0 is going to be 1. So even if you have 10 million raised to the exponent of x, if that is the equation of your exponential function, still the y-intercept is going to be 1. So this was a little bit different. This one, again, x-intercept and y-intercept are both 0. This one, the same story, as you see. Reciprocal function, well, x is an invalid input number for the reciprocal function. You cannot divide 1 or any number by 0. That means that x cannot equal to 0. And that's the reason why we have this big gap or break in the heart of this graph of the reciprocal function. And the y-axis plays the role of vertical asymptote, actually, for this reciprocal function. So x-intercept or even y-intercept, they don't exist. None of them exist, because the graphs are neither intersecting the x-axis, these two branches of the graph, neither intersect the x-axis nor the y-axis. So we're going to say no x-intercept and no y-intercept. Okay, I had told you before, to find x-intercept, we set y equal to 0. But if you set y equal to 0, you get 0 equals 1 over x. Good luck solving for x. 1 over x is never ever equal to 0. What does that mean? It means that you are not going to have any x-intercept. And when you plug in 0 for x for the purpose of finding the y-intercept, then you'll be faced with the problem of dividing 1 by 0, which is undefined. So again, the message is that there is no y-intercept. So we are saying none and none. Some people by mistake, they say 0, which is totally wrong. Okay, then we have intervals of increase and decrease. So this graph, the linear function, is increasing from negative infinity all the way towards positive infinity. You see that if you move from left to right, okay, the values of y increase. So interval of increase is negative infinity up to positive infinity. Does this function decrease at all? No. So we're going to say there is no interval of decrease. It's not your fault that the function is not decreasing. Parabola is totally different because it's decreasing before. The values of y are decreasing from left to right. So see 9, 4, 1. What's happening? It's decreasing. And then after 0, it goes up, increases. 1, 4, 9. What's happening? Increasing. So decreasing first, from 9, going down to 4 and 1, and then increasing, going up to 1, 4, 9. So I'm going to say interval of increase is from 0 to positive infinity. Interval of decrease is negative infinity up to 0. For this one, it is increasing from 0 to positive infinity, but it does not decrease at all, so there is no interval of decrease for the square root function. This other function is always increasing, as you see, from negative infinity to positive infinity. It is always increasing, and there is no interval of decrease. It's not your fault. Cubic function, again, it's always increasing from negative infinity to positive infinity, and it never decreases. Absolute value function, first from left to right, it decreases. You see the numbers 3, 2, 1. It's going down, right? And then afterwards, it's going up 1, 2, 3, right? So from negative infinity up to 0, it is increasing. And then from 0 to positive infinity, the graph or the function is increasing. And here I'm using interval notation to represent these intervals of increase and decrease. Square root function, it starts from negative infinity, and as you see, it is decreasing. And if you look at the numbers, it is like negative 0.5, negative 1, negative 2. These values are decreasing. And after 0 to the right, again, the values 2, 1, 0.5, these numbers are decreasing. So basically, it's a function that is decreasing. It's not increasing at all, so I'm going to put 9 because it's not increasing. But decreasing, I'm going to go from negative infinity up to 0, and then from 0 to positive infinity. Okay? So there's two intervals basically here. One is on the left side of the y-axis, one is on the right side of the y-axis. And I have to sort of combine these two intervals. And how do you show this? How do you write this in mathematics with proper notation? It is called the union notation. So I'm going to put down this union symbol. Okay, looks like a U. Sometimes it's called cap. Okay, we have cup and cap. See, cup is like this, and cap is like that. This symbol stands for union of two sets of intervals, and the other one stands for intersection of two sets or intervals. So here we are combining two sets or two intervals, and we can't write the plus sign because we're not adding numbers. We're talking about sets of numbers. We're talking about intervals. Therefore, we use the union symbol to combine these two intervals. And here we're saying that from negative infinity up to 0, all the way up to 0, excluding 0, the function is decreasing, interval of decrease. And then this is combined with another interval from 0 to positive infinity. Okay, we are sort of excluding 0 because 0 is a taboo for this function. It's an invalid input number. Last property, domain and range, you already know. Domain here is the set of real numbers, and the range is also the set of real numbers. So x belongs to the set of real numbers. Here, domain is the set of real numbers, but the range is only y values that are greater than or equal to 0. So we're talking about points on the parabola that are above the x-axis in the positive region, including the origin or the 0, of course. Next function, x has to, of course, belongs to the real numbers such that x has to be greater than or equal to 0, because square root function is defined only for positive values. Okay, you can't have square root of -4. Punching on the calculator, you see the error message right there. So the square root function is defined only for positive values of x. That's why I say x is greater than or equal to 0. That's the domain. But the range is again above the x-axis. So y is greater than or equal to 0. For this one, x belongs to the set of real numbers. Domain is like any real number, but the y has to be greater than, and actually only strictly greater than 0. Okay, so I'm saying here y belongs to the set of real numbers such that y is greater than 0, only greater than 0. I'm not saying greater than or equal to 0 because we just said that there is no x-intercept, right? This one, it's going to be a set of real numbers for both of them. The other one, x belongs to a set of real numbers for the domain, but the range is going to be greater than or equal to 0. Any real number such that y is greater than or equal to 0. That's the range. And for the reciprocal function, domain is any real number such that x cannot equal to 0. But other than 0, you could have selected any other x value in the table of values. The only invalid input number here is 0, and that's why we are excluding it from the domain of the function. And the range is again y that belongs to the real numbers, and y cannot equal to 0 for the obvious reason that we said that we don't have an x-intercept. So we have 1 over x, and that 1 over x, that fraction can never equal to 0 because the numerator of the fraction is 1, and 1 is not 0, obviously, right? So this takes care of 7 different basic functions that we need to know perfectly. And I think I did everything for you, but you got to just review this, of course. You're going to watch this video several times. Due to time restrictions, I have to speak fast. I have to move on very fast. But you have the advantage of pausing and reviewing and watching the lecture video like 10 times if you want. I discussed domain and range. I discussed intervals of increase, decrease. I discussed x-intercept, y-intercept. I discussed the table of values. I discussed the graphs of the basic functions. I discussed their equations. And the topic was 7 basic functions. I hope you understood this, and I hope you are going to watch this many times, and you are going to actually graph these by yourselves on a piece of graph paper so that you have a better understanding. Thank you for your attention, and keep practicing.